So the first part is just the preamble. It doesn't really matter. It says, note that two new variables are added to the case. I don't know what that refers to. Total time equals prep time plus wait time plus travel time. On time is 1 if total time less than or equal to 29, and 0 if total time is greater than 29. So this definitely refers to a data set that I do not have. Or
Okay.
if you think I have it, it's definitely not the statistical tools matrix that looks like just a kind of a
Oh,
helper.
I'm so sorry. Yeah, so the Presto Pizza case, that is an upcoming case that we will have the data set for. So that's what that's
Okay.
referring to. Okay.
All right, so there's no way to do this problem unless
Okay.
we have that
Have
data.
that.
I mean, I can talk generally about how to do a 95% confidence interval on proportions, but I need more information to be able to help you with this problem here.
Okay.
Uh, when I look at, for example, question 2,
Mhm.
kind of same thing. We need the data set. So
Okay.
is that something you can get over to me or?
Yeah, let me minimize this real quick. Let me Presto Pizza. Download. All right, I'm gonna send it to you right shortly right now.
This looks like a graduate class, is that correct?
It is.
Okay. So they tend to be much more helpful in graduate classes because they do want to make sure you guys, finish off the course and they don't want to see you be left behind. Um, do you know if your teacher plans to be available to kind of work these problems out with you guys enough so that you'll know how to work them out for them on the test quiz? I mean, are they leaving you off on your own for everything?
Pretty much we're kind of on our own. I mean, she's available, but you know, I've I've talked to different teachers before, and they're kind of like, "This is basic math," and I think I had that conversation with you where it was just kind of like, "Hey, this is basic. Like, I don't know why you're struggling."
Well, we know now that we need the data set to be able to do anything
I
for
just
uh
sent
for
that.
this. Yes, and you sent
Yeah.
it over, which is perfect. So, all right. So I've got this data set up. All right, so we can go back to this first problem here. So it says estimate with 95% confidence the true proportion of pieces that we delivered on time if the 29-minute guarantee were implemented. Okay, so we're looking for something that's on time if total time is less than 29. Total time is prep time plus wait time plus travel time. So what I'm gonna do here is I'm gonna switch and go over to the Excel here so you can see uh, how to do some things with this. Let me switch over to that screen here. I'll make the just a tiny bit bigger. Looks like you're seeing that now. All right, so we've got to add a new column here for total time because we didn't have that. Keep total time. So total time is the sum of prep time plus wait time plus travel time, like that. And we can just copy this formula down. Are you pretty comfortable with Excel, or would you like some explanation on what I've done just there?
No, I saw that you added them together, and then you're gonna drag it down.
Yep. Then I'm gonna just add a little if statement here. If this value to the left here is less than or equal to 29, we put a 1 and a 0 otherwise. Are you familiar with if statements, or is that totally foreign to you?
Um, can you? I know that it changes the number, but
We're
I
we're
don't.
not going to yeah, we're not going to be we're basically just checking if this number in
Mhm.
G2 is less than or equal to 29. We want to put a 1 there because it says that means it's on time. On time is
Okay.
less than or equal to 29 minutes. So for example, here, we expect this one to be on time, but is there one that's not on time? Well, most of these look like they're on time. Nope, there's a few that are not. So you can see like the 32.88 is not on time
Mhm.
because its sum is greater than or equal to 29. You can see a few more down here.
Oh, gotcha.
So somehow you have to be comfortable doing that. We can work that out,
Okay.
or we can do more of that if we want. 2. Now, the last to actually do the 95% confidence interval,
Mhm.
what you need is the number that are on time. Like how many are on time out of the total.
Oh, okay.
Okay. So that's where it would be nice to know how many pieces of data are in this data set, which there's not really an elegant way of doing this. Looks like there's 241 pieces of data, but then you have to subtract the first row. So there's 240 pieces of data here. And then what I, it depends on your comfort level with Excel. You can just do a sum of this column here to figure
Mhm.
out how many of the 240 are on time, which is 207 out of 240. Normally this information is given to you, but in the structure it is not. So we go back to the other screen here, 95% constant interval. So there's this thing called P. P is X divided by N. X in your case is 207 out of 240, like that.
Mhm.
And then from here, you need the confidence interval formula for a proportion. So let me see if you guys have that. So I'm looking at the other thing that you had here. This is the statistical tools matrix confidence interval on a proportion. It's in the second tab there, but the this isn't right.
Is that using like a t-test?
It shouldn't be using a T, it should be using a Z. So you may want to ask your instructor why that's there. That's completely wrong. Um, Probably because they copied and pasted it from the previous one, but it is a Z.
Okay.
And this 0.025 can be depending on what confidence interval you want, it could change. But what we calculate is called P bar. So you actually have everything that you need except for this right here. So the Z of 0.025, you can either get from Excel or maybe you have a table. Are you familiar with Z scores or
I
not?
am. I am.
Okay. So this
Mhm.
one I believe is 1.96. So to do this by hand, without software is you get this number or you can reuse it, but it's 207 out of 240 plus or minus 1.96. That's a Z square root 207 out of 240 times 1 minus 207 out of 240 over 240 like this.
Is real
Uh,
quick, is our degrees of freedom, is that n minus one or?
There are no degrees of freedom in a proportion. Proportion confidence intervals use the Z interval, the Z distribution, normal distribution always.
Oh, okay.
To answer your question though, yeah, I mean, degrees of freedom for a t-test, which we don't have, is n minus one. T-test, if it's one one set of data. Yeah, maybe bring this up to your instructor, maybe get a bonus point there for being, you know, noticing a mistake in the key there. What kind of calculator are you going to use in this class?
It is an HP prime.
Okay, I don't know that one. Are you comfortable calculating this?
Yes. Yeah, I
Okay.
am.
I'm happy to do the calculation here if we need to. We'll also move on to another question.
So real quick, so to get the Z score of 1.96, that is basically going to the 0.025. And then how do you go down? Like what number are we using to go down?
Well, it's 0.025 in each tail. So
Right?
in a lot of calculators, they have like an inverse norm
Okay.
function where you put in the area and the tail, and then it
Okay.
returns 1.96. So the one the
Oh.
the 0.025 is the area. This is
Mhm.
the Z value. So the Z is along, this is the Z axis, and
Right.
and the area is literally the area. Yeah, these are good. Keep the questions coming because that's probably where the learning gaps are at this point is you're just not sure about some things. So let's get those questions answered. And I'm doing this calculation here. The upper bound is 0.906, and then the lower bound is 0.819. And in terms of like the question, it doesn't ask for it, but you're basically saying that the group proportion of pizzas that would be delivered with the guarantee is between 81.9% and 90.6%. So you could reasonably claim 90% on time.
Oh, okay. Gotcha. And just real quick, how did you come up with the upper and lower bound?
Using this formula up
Oh,
here.
okay. In that
Plus is
case.
the upper, the minus is the lower. And I would
Oh,
encourage you to do the
I see.
calculations. Like I would
Okay, you did the
definitely
calc.
recommend
Okay,
doing this just to make sure you're comfortable.
okay, that makes sense now. Well, cool. That's
Right.
awesome.
Okay, so the next question we had here was, it says, what is the best measure of central tendency for wait time and travel time? So the best way to figure out central tendency is to have some sort of a graph of the data set.
Mhm.
And typically you look for like a histogram to see the shape here. Now, Excel does not have a very good built-in histogram feature,
Mhm.
um, fortunately. So what I'm going to do here is go to another piece of software that I like that's free. I don't like it because it's free. It just happens to be free. Usually free, you get what you pay for. Um, disk, stat disk, there it is.
So what's really interesting too is that, we're not allowed to use Excel for our final, but then she has used a histogram.
That sure looks like you need Excel. There's no
Yeah.
way to do this one by hand. So this is one of those where maybe they just grabbed the one from last year and or
Okay.
they've had it up, and I don't know. You gotta be really careful here that don't practice something that isn't going to be on the final. So
Mhm.
let me put this in here. All right, so this website, I'll put it in the chat here. It's statdisk.com. It's a pretty good piece of software. One of the
Okay.
advantages of working with me is I have a lot of these resources that I figured out, so you don't have to. But with this one, I can do a histogram. First one, let's do a plot. So here we go. I'm going to snip this in. All right, so this is wait time.
Oh wow.
And then the other one is what is it? Travel time. All right. So what I notice here, and what they're hoping you will notice, is that the one on the right is pretty normally distributed.
Mhm.
It's like that bell curve. So if you just draw a rough sketch, get like something like that, that's what we expect here. One on the right is definitely not. It's more of like an exponential distribution. Or if you have no idea what that is, it's definitely, you could just say it's not normally distributed. So when you use the normal distribution, the mean typically equals the median, typically equals the mode. Basically, the mean is probably a good estimate here
Mhm.
of it. When it's not normally distributed, the median is typically the best, or the mode.
Okay.
And this may be a question for your instructor, because when they're giving you this question, they have some thought that they're thinking about when they're graphing this. Like, you'll see a slide somewhere that says, if it's got this shape, use the median or use the mode. You might want to go to your teachers. Hey, I was working on this problem over the weekend and I got a graph that looks like this. Um, you know, I know it's not the mean. Do you recommend us using the median or the mode?
So this one would be like an extreme outlier, right? That would.
Mm, maybe, but like wait times, it's kind of like if you go to a restaurant, your wait time is expected to be pretty low
Mhm.
most of the time. Like most people aren't waiting this long for a table. Whereas travel time, like depending on where they live, it could be really close or really far. You're not really constrained by anything. But wait times, you typically know, okay, I'm gonna wait some amount of time, but not forever.
Mhm.
Because people just get up and leave. That's what I do. You tell me there's a 60-minute wait, I'm out. I'm out. I'm not gonna do it.
Mhm.
So to answer this question, you do need Excel, you need the data set,
Okay.
you know, like we've been talking about. It's like, well, I don't know what to tell you because it's this may be not representative of that. All right,
Right.
number three here is a pure kind of uh like they have certain words that they want to see. So it says the 95 confidence interval for day is 3.85 to 4.35. So the way this works is there's kind of a recipe here. It says the um the true day is between 3.85 and 4.35. So there's kind of this parameter. So we are 95% confident that
It's gonna be between.
the true day, like whatever that refers to, which I believe it's the day of week. Now this is like the correct mathy answer. You may want to like dress it up a little bit with and say, that we know this is implies Wednesday and Thursday are the implying Thursday, Wednesday, just maybe making some reference to what day a week it is. I don't know if we know that in the actual data set. It would
Mhm.
have to tell you which day it started with.
Right.
And I can't tell. Like they have to give you they have to tell you that day one, you'd have to know that day one means, Monday, or maybe it means Sunday. I don't know. Depends on your view.
Okay. The case. Yeah, it's probably in the case itself.
Yes. Okay. So next kind of thing here. Uh, all right. So this is your kind of your classic probability question here. It says, what is the probability that on any specific delivery, the order will be late? We're asking the probability that X is greater than 29 in this problem. We assume that it is normally distributed. Okay. So what that means is, remember that column for total time that we had in the other Excel thing? We
Yeah.
need the mean and we need the standard deviation. We already know the number of samples is 240. So let me quickly get those for us so that we can do this calculation. So the average total time is 25.32. The standard deviation is, and I'm just using the built-in functions in Excel for that. We can certainly go through that maybe in another time here. So 3.92, like that. So there's a couple of ways to do this. Like you can go, oh, you're doing it by hand. So you've got to calculate a z-score. Z is equal to x minus mu over s divided by the square root of n, except we probably should use the t distribution. However, your degrees of freedom, like you're mentioning, is so high, you may not have this
Uh,
option in yours
yeah.
if you're looking at a table, but it generally becomes the normal distribution once this high. So yeah, it's we'd have to look into that a little more, but it's 25.32 minus 29 over 3.92 divided by the square root of 240. So we'd want to get this value,
Be
and we'll do
greater
that
than.
here. Yeah, we'll do this real quick here. Oops. All right, 25.32 minus 29 over 3.92 divided by the square root of 240. Wow. Okay. So this is pretty small, minus 14.54. So what that is even on the t distribution looks like this is way over here.
Mhm.
So we want the probability that it's going to be more than 29 minutes. Sorry, I flipped these. That's why this is wrong. sorry, 29 minus 25.32. And that's actually over here on the right. It'll be positive. And so basically it's like how much area is in the tail,
Hmm.
and it's essentially zero. So your p-value of 14.54 is essentially zero, or your t distribution. Basically, it never happens. So you're pretty confident that, hey, we're pretty solid here on this. All right.
Great.
I'm gonna go ahead and stop the